Now welcome to the next session. In this session, we continue classroom workbook. Let us start the session from question number 5. Question number 5. Given the following data, x values are 1, 2, 3. P of x values, probabilities like this: 0.3, 0.6, 0.1. So the PDF is given like this: P of x is 0.3, P of 2 0.6, P of 3 is 0.1, where x is a discrete random variable and P of x is the probability distribution function. The standard deviation of x is, so we need to find standard deviation of x. Actually, for standard deviation, variance is required, and for variance, mean is required. So at first, let us try to find mean value. E of x is 1 into 0.3 plus 2 into 0.6 plus 3 into 0.1. So this is 0.3 plus 1.2 plus 1.3. So therefore this is 1.8. So here mean value is 1.8. Now variance is evaluated like by this formula. Sigma x square is E of x square minus E of x whole square. Now this E of x square is 1 square into 0.3 sample point square into probability plus 2 square into 0.6 plus 3 square into 0.1 minus this E of x is 1.8. So 1.8 whole square. Now let us simplify this. This is 0.3, 4 into 0.6, 2.4, 9 into 0.1, so this is 0.9 minus 1.8 square is 3.24. This is 3.24. Now this is basically 3.6 minus 3.24. So therefore here this is 0.36. So variance value is 0.36. So here the standard deviation is positive square root of sigma x. So the square root of this 0.36 is 0.6. So option D is right answer. A random variable x has a PDF f of x as shown below. F of x is like this: a plus bx if 0 less than x less than 1, 0 otherwise. If the expected value E of x equal to 2 by 3, then the value of P of x less than 0.5 is what? So it's a blank question. This is the PDF of a continuous random variable a plus bx, where x lies between 0 to 1. Outside the limits, the PDF is 0. And expectation of continuous random variable x is 2 by 3. Then what is P of x less than 0.5? Now let us write the formula for this at first. Here this is P of x less than 0.5. So here upper limit is 0.5. But for continuous random variable, the lower limit is infinity. But here the lower limit of the function is defined as 0 only. Only from 0 to 1 the function is defined. Outside the limits it is 0. Because when you look at continuous random variable, it looks like P of x less than or equal to a. Upper limit is a, lower limit is minus infinity. But here upper limit 0.5, that is okay. But here lower limit is 0. Therefore, this will be integral 0 to 0.5 f of x dx. So, therefore, this is 0 to integral 0 to 1 by 2 f of x means a plus bx dx. Therefore, to get the value of this integral, I must know the values of a and b. Now, how to get the values? Use this condition: expectation of x is 2 by 3. When you use E of x equal to 2 by 3, you get one equation in terms of variables a and b. Since it is a valid PDF, when you integrate this function between 0 to 1, the result is 1. See here, I want to get this value. That means I should know the values of a and b. If I don't know the values of a and b, I cannot integrate this function, right? So therefore, if I want to get two values a and b, I must establish two equations in terms of variables a and b. Now one equation can be framed by using e of x equal to 2 by 3. And second equation can be established among a and b using the validity of a PDF. Since it is a valid PDF, when you integrate this from 0 to 1, the result is 1. So if you use that strategy, you get one equation in terms of a and b. If you use this strategy, you get one equation in terms of a and b. So therefore, we get two equations in two variables a and b. Solve those two, you get the values of a and b. Once you get values of a and b, so simplify this integral, you get the answer. That is required for us. Okay. Now let us see. Since f of x is a PDF, implies, of course, limits are from 0 to 1 only. So integral 0 to 1 f of x dx must be equal to 1. So this implies integral 0 to 1, this is a plus bx dx equal to 1. Therefore, this is ax plus bx square by 2. Limits are from 0 to 1, 1. Therefore, this equation is a plus b by 2 equal to 1. Therefore, 2a plus b equal to 2. This equation, we got one equation. So, 2a plus b equal to 2. Now, let us apply this one, e of x equal to 2 by 3. So, e of x means integral 0 to 1 x into f of x dx equal to 1. Actually, what is expectation of continuous random variable? Integral minus infinity to plus infinity x into f of x dx. But here limits are from 0 to 1 only. Therefore, when you simplify this, this becomes integral 0 to 1 x into a plus bx dx equal to 1. So, integral 0 to 1 ax plus bx square dx equal to 1. Ax plus bx square dx equal to 1. Therefore, this is ax square by 2 plus bx cube by 3. Limits are from 0 to 1 equal to 1. Apply upper limit, we get a by 2 plus b by 3 equal to 1. So, the LCM is 6. So, this is 3a plus 2b equal to 6. Now, we got second equation in the variables a and b. Now, let us, this is one equation, this is another equation. Let us solve these two equations. Now, these two equations, what is my equation 1? 2a plus b equal to 2. So, let us multiply equation 1 with 2. So, I get 4a plus 2b equal to 4. Second equation is 3a plus 2b equal to 6. So, subtract these values. First equation is 2a plus b equal to 2. Second equation 3a plus 2b equal to 6. Therefore, when you subtract this, the value of a seems to be, subtract from this, you will get a value minus 2. Let us verify calculation once again. This is a plus b by 2 equal to 1. So, this is 2a plus b equal to 2. So, second equation is ax square by 2 plus bx cube by 3. Limits are from 0 to 1. So, a by 2 plus b by 3 is 1. LCM is 6. When you multiply with 6, you will get 6a plus 2b equal to 6. Now, this equation is, you subtract from this, a value we were getting 4 minus 6 minus 2. A value minus 2. So, substitute a value in any one of the equation. So, a value, the equation is a plus bx. Actual expectation of x is 2 by 3. So, here we wrote 1 in place of 2 by 3. This is 2 by 3. Now, therefore, this is a 2 by 3, 2 by 3. So, 2 by 3. When you multiply with 6, you will get 4. So, second equation is 3a plus 2b equal to 4. Now, subtract this. So, the value of a becomes 0. When a is 0, b becomes 2. Therefore, this becomes integral 0 to 0.5. This is 2x dx. So this is x square from 0 to 0.5. So 0.5 whole square, this is 0.25. Therefore, the value of p of x less than 0.5 is 0.25. So write this is given by f of x equal to x by 4 into 4 minus x square for 0 less than or equal to x less than or equal to 2. 0 otherwise. So here PDF is given for a continuous random variable. Limits are from 0 to 2. The mean of x. So we need to find expectation of x. It's a blank question. So the expectation of x is actually integral minus infinity to plus infinity x into f of x dx. But here limits are ranging from 0 to 2 only. So therefore here limits 0 to 2 x times f of x is x by 4 into 4 minus x square dx. So therefore this is 1 by 4 into integral 0 to 2 4x square minus x power 4 dx. So therefore this e of x equal to 1 by 4 into integral 4x square is 4x cube by 3 minus x power 4 integral x power 5 by 5. So here the limits are from 0 to 2. So therefore this is 1 by 4 into 4 into 2 cube 32 by 3 minus 32 by 5. So this therefore 32 by 4 this is 8 into 1 by 3 minus 1 by 5. So therefore 8 into 5 minus 3 divided by 15. So 16 divided by 15. So therefore the value of expectation of x is 16 by 15. 16 by 15. Ram and Ramesh appeared in an interview for 2 vacancies in the same department. The probabilities of Ram's selection is 1 by 6 and that of Ramesh is 1 by 8. What is the probability that only one of them will be selected? So what is P of Ram? 1 by 6. P of Ramesh, probability of Ramesh selection is 1 by 8. So only one of them must be selected. Both appeared in an interview for same vacancy. So only one of them must be selected. So the required probability is like this. If Ram gets selected, Ramesh should not be selected. So the 2 chances. Ram is getting selected. In that case, Ramesh should not be selected. So P of Ram dot P of Ramesh bar. So Ramesh should not be selected. So this is the complement of getting selection for Ramesh. R means plus. Ram should not be selected. So that means complement of Ram. But Ramesh has to be selected. So dot P of Ramesh. So see, probability of Ram selection is 1 by 6. Ramesh selection is 1 by 8. Only one must be selected. If this fellow gets selected, this fellow should not be selected and vice versa. So Ram is getting to be selected, so Ramesh should not be selected. Actually both are independent events. So we got dot here. So P of Ram dot P of Ramesh bar, or Ram should not be selected, Ramesh should be selected. So basically this bar represents a complement. So what is P of Ram? P of Ram is 1 by 6. Ramesh should not be selected. Now we have one simple result connecting probabilities. P of E plus P of E bar equal to 1. Very basic result. Now therefore Ramesh should not be selected. So it's a for selection of Ramesh, probability 1 by 8. To not select Ramesh, this probability is 7 by 8. So 1 minus of this. Ram should not be selected. 1 minus 1 by 6. 5 by 6. Ramesh has to be selected 1 by 8. So therefore this is 7 by 48 plus 5 by 48. So this is 12 by 48. So the answer is 1 by 4. So option B is right. The probability that it will rain today is 0.5. The probability that it will rain tomorrow is 0.6. and the probability that it will rain either today or tomorrow is 0.7. So R means union. What is the probability that it will rain today and tomorrow? That is intersection. Now assume that E1 is an event of raining today, and E2 is an event of raining tomorrow. So therefore, what is P of E1? Probability that it will rain today is 0.5. Probability that it will rain tomorrow, that is P of E2 equal to 0.6. The probability that it will rain either today or tomorrow is 0.7. That means P of E1 union E2 is 0.7. Then they were asking what is the probability that it will rain today and tomorrow, and means intersection. So we need to find out this. P of E1, P of E2, P of E1 union E2, all the things are given, we need to find out this. So here P of E1 intersection E2, this is given by P of E1 plus P of E2 minus P of E1 union E2. So here P of E1 is 0.5, P of E2 0.6 minus P of E1 union is 0.7. So this is 1.1 minus 0.7. So therefore this is 0.4. So option D is right answer. The probability that a number selected at random between 100 and 999, both inclusive. Both inclusive will not contain the digit 7 is. This is very interesting question. Of course, this question is based on combinations. So we need to select a number between 100 and 999, both inclusive. Both inclusive means you can select 100 or you can select 999 also. Generally, when you say numbers between X and Y means the X and Y may not be included. But here they were mentioning very clearly you can take 100, you can select even 999 also. Now let us see. The sample space S is this. S equal to 100, 101, 102 and so on up to 99. Now how many elements are there in S? Actually everything is a 3-digit number. So actually the number of elements in S equal to 900. The number of elements in S is 900. You can see from 1 to 1000 we have 1000 numbers. But here first 99 numbers are not included. So eliminate 99. Last number is not included. So subtract one more. So totally you will get 900 numbers. So from 1 to 1000 we have 1000 integer values. So first 99 numbers are not included. So subtract 99 from 1000. And last number 1000 is not included. Subtract one more element. So subtract 100 from 1000, you will get 900. Therefore the total number of points in S is 900. So everything is a 3-digit number. Everything is a 3-digit number. So you need to select a number. So the required probability is this. The probability is a 3-digit number. So every number inside S is a 3-digit number. So XXX for example. So how many numbers are there in S1? 900. You select one number. So that can be done in 900 C1 ways. So therefore the probability is XXX divided by 900. Now let us see. Actually whenever you select a number in the S, it should not contain digit 7. Actually 7 should not be there. 7 should not be there. 7 should not be there. So actually a 3-digit number cannot start with 0 also. The total number of digits in the number system is 9. 0, 2, 3, 4, 5, 6, 7, 8, 9. So totally the total number of digits including 0 is 10 digits. Including 10. 0. So total number of digits is 0 to 9, 10 digits. But a 3-digit number cannot start with 0. So therefore this X cannot be filled with 0 as well as 7. Therefore it has only 8 alternatives. But this can be filled with 0, no issues. But 7 should not be there, so 9 chances will be there. Here also 9 chances. So the probability is 8 into 9 into 9 divided by 900. So therefore this is 72 by 100. So therefore 4 18s, 425. So the required probability is 18 divided by 25. So option D is right answer. Let me explain once again. Here we need to select a number from 100 to 999 both inclusive. So therefore I am taking a sample point, sample space. S contains all numbers from 100 to 999. The number of values, the number of numbers in S is totally 900 numbers. Because from 1 to 1000 total number of digits is, total number of values is 1000. But first 99 numbers are not there. Last 1000 is not included. So subtract 100 numbers. So finally we get 900 numbers. So how many elements are there inside S? 900. But all 900 numbers are 3-digit numbers. So you select one element from S. So the denominator will be 900C1 probability. Number of times the event E occurs divided by total number of points in the sample space. 900C1. So 3-digit number. Actually, how many digits are there in the number system? 10 digits including 0. But a 3-digit number cannot start with 0. Of course, it should not contain 7. The problem is given. So therefore this can be filled with 0. I mean 1, 2, 3, 4, 5, 6, 8, 9. 8 chances. Except 0 and 7, you can fill this. But this cannot be filled with 7. 9 chances. This cannot be filled with 7. 9 chances. So the probability is 8 into 9 into 9 by 900. It is 18 by 25. So option D is right answer. Two events E1 and E2 such that P of E1 equal to 1 by 2, comma P of E2 equal to 1 by 3, and P of E1 intersection E2 equal to 1 divided by 5. P of E1 1 by 2, P of E2 1 by 3, P of E1 intersection E2 equal to 1 by 5. Then which of the following statements is true? Let me write the options. First option is P of E1 union E2 equal to 2 by 3. So E1 and E2 are independent. See, E1 and E2 are not independent. Now option D, P of E1 slash E2 is 4 by 5. Now which of the following is true? See, out of these 4 statements, checking whether the events are independent or not is very simple for me. Even I can get this also. P of E1 union E2 I can find. P of E1 union E2 is P of E1 plus P of E2 minus P of E1 intersection E2. If I get 2 by 3, this will be right. Otherwise, this will be wrong. Even I can find this P of E1 intersection E2 is P of E1 slash E2 is P of E1 intersection E2 divided by P of E2. P of E1 intersection E2 is given, P of E2 is given. But checking whether the events are independent or not is very simple. If the events are independent, then what will happen? P of E1 intersection E2 must be equal to P of E1 dot P of E2. But here P of E1 intersection E2 is 1 by 5. P of E1 dot P of E2 is 1 by 6. So these are not equal. So P of E1 intersection E2 is not equal to P of E1 dot P of E2. So they are not independent. So option C is right answer. Very simple to verify. If they are independent events, P of E1 intersection E2 must be P of E1 dot P of E2. But 1 by 2 into 1 by 3, that is not equal to 1 by 5. So they are not independent events. So option C is right statement. So the constraints, P of E1 equal to P of E2. P of E1 union E2 equal to 1. E1 and E2 are independent events. E1 and E2 are independent events. So in that case, we need to find what is P of 1, E1. So the data is given like this. P of E1 is P of E2. P of E1 union E2 is 1. They are independent events. Then what is P of E1? So let X equal to P of E1. Now let us apply addition theorem on probability. P of E1 union E2 equal to P of E1 plus P of E2 minus P of E1 intersection E2. So P of E1 union E2 is 1. P of E1 X, P of E2 X. Here these two are independent events. So this becomes P of E1 dot P of E2. So therefore X into X, X square. So therefore X square minus 2X plus 1 equal to 0. So this implies X minus 1 whole square is 0. So this implies the value of X is 1. So therefore P of E1 is 1. P of E1 is 1. So the answer is D.